sometimes chemical reactions are following the rules of square dancing. What's the square dancing? You know, in square dancing, partners are switched. So if I have a binary compound, meaning it's not composed of one type of atom, reacting with another binary compound, the product can be predicted by simply switching the partners. So A is replacing C. So now A is a partner with D. And C is replacing A. So C is partner with B. So again, square dancing, switching partners. How do you know it is double replacement or single replacement? In a single replacement, you must have a single element, single type of atoms. In double replacement, it's binary. At least two atoms bonded together. You don't have elements which are composed of one atom. Do you see a binary compound here? Yes, NO3 is negative charge, Ag is plus charge. If you break these two from each other, you can say I have a binary compound composed of oppositely charged atoms, two different ions, oppositely charged ions. Let me clear the board so it's not confusing. So can I say NO3 has negative charge? How do I know? There is a table on your exam table. There is a table on page 89 of your book, which gives you the charges of polyatomic ions. See, NO3 is a polyatomic ion. It means it's ion which is composed of more than one atom. So do you see there are 4 atoms involved, 3 oxygens and 1 nitrogen in making this ion? Of course, some atoms are single atomic. This is single atomic ion. We don't call them single atomic. When we say polyatomic, that means they are not single atom. So if you are not sure what the charges polyatomic atoms are, just go ahead to page 89, look them up. That table is available to you during the exam. So if I have, and I know metals have positive charge, these are two oppositely charged ions. They are composed of more than one atom. So binary compound, separation of positive and negative, separation of positive and negative. So, sorry, the positive ions, metals are going to switch their place. So Ag becomes a partner with Cl. And Na is going to replace Ag. So Na is now a partner with NO3. So this is the product of this reaction. How do we know this reaction is actually happening in test tube? Well, actually, you'll see this is making a solid, which is a cloudy solution. The appearance changes. So say there is a reaction. There is an observable signal which tells us reaction is going. Once you see the reaction, you're predicting product by the fact that you have 2 binary compounds. There is a reaction, so the product can be predicted by double replacement. The positive ions switch place. The positively charged ions switch their place. So in this experiment, again, do you see you're reacting? You are reacting Can I say zinc sulfide is a binary? But this is -2 and this is +2. Can I say HCl, strong acid, breaks down to positively charged hydrogen and negatively charged chloride? This is a binary. The two positives switch their place. The zinc is replacing hydrogen, becoming a partner with chlorine. And hydrogen is replacing zinc, becoming a partner with sulfide. Again, we want to make sure once we do the replacement, products follow the laws of writing ionic compounds. That means charges must add up to be 0. And that's the case why zinc is not zinc Cl, it's zinc Cl2, because -2 and +2 add up 0 and +2, and 1 chlorine is -1. They are not adding to be 0, so that's not the place. So that's not correct. So when you do the switches in double replacement, just like single replacement, investigate the formula product, make sure they follow the rules of charges must add up to be 0 in an ionic compound. Do you have any question, guys? Anybody? All right. So that's another example of double replacement reaction. Barium, sodium, both of them metal, both of them have positive charge. They replace each other, and barium is now partnered with SO4, and sodium becomes partner with Cl. Of course, we cannot write Na2Cl2 because both of these subscripts are divisible by 2, so we always write the simplest ratio, 1:1. So this formula is not correct. Although you add charges to be 0, but always investigate the subscript. What's the simplest ratio? 2:2 is the same as 1:1, so we write 1:1. You have 2 sodium on the left, so you place a 2 here. So 2 NaCl, not Na2Cl2. You are in the lab and you are going to observe this on the PLP. What is the evidence that there is any reaction? You need a visible, a sensible change that there is a reaction. Do you see a clear solution of sodium sulfate or barium chloride, doesn't matter, is adding to a clear solution? Immediately after addition, do you see formation of cloudiness solid? So this is telling you, yes, there is a reaction. And then you predict the product by what I said, double replacement reaction, writing correct formula, balancing equation, so you have same number of atoms on both sides. Any questions, guys? Don't hesitate to come and see me after you study the book. You look at this, do a few problems, make a list of things which you don't understand. Come and see me during office hours. And during the afternoon sections on Tuesday and Thursday, 11 to 3:20. Those are the lab times. I can help all of you. Doesn't matter whether you are in my lab or not. Although there are 3 instructors which are available to help you during your lab time. Next. So we want to classify The following reaction, are they single replacement or double replacement? If I go through these, if I want to see what is single replacement, do I need a single element which hasn't made a bond? Do you see this is single? It's Al made of one atom only. Carbon, C is one atom of, it's one type of atom. I didn't mean one atom, one type of atom. There is no bonding between carbon and any other atom. There is no bond between Al and any other atom. Can I say these contain single, so it should be single replacement number 1 for this and 1 for this. And do you see I don't have a single here? Do you see both of these are binary, different types of ions, -2 for sulfate. How do I know? Check page 89 of your book. That's where you get the charges of polyatomic ions. And sodium +1, 2 sodium becomes +2. And do I see a binary compound here? Negative charge for polyatomic ion nitrate. And positive charge for silver. Metals always have positive charge. So when you add these two together, if you are doing in the lab, if you are observing a video, you will see formation of a precipitate. This is actually a solid. So you know there is a chemical reaction. How do I write the product? Double replacement, which is 2. That means sodium is replacing Ag. So do you see sodium is a partner with NO3 and Ag is replacing Na. So Ag2 SO4. So Ag is a partner with sulfate. So this is the only one which double replacement, which is double replacement reaction. And A and C are single replacement reaction. Do you have any questions, guys? Any questions? All right, I go to the next. Again, you can only learn this thing definitely by studying the book and doing the problems. Lots of good examples in the book. There are solved examples, and then they ask you exercise on similar problems. The answers are available on the back of the book. And I'm here to help you. One-to-one basis, it really helps when you come face-to-face and ask your questions. Next,